Hello friends, my name is Bkk Kolhapure. In earlier videos we have seen how to find out the load in the column by using Euler's method and Rankine's method. So cross section was given to you, you are finding out the load. Today we will see load is given to you and you will have to design the cross section of the column. So this is the last type of category what you come across columns. Suppose if I take a circular column, hollow circular column, if it is hollow at the center, if D is the external diameter of the column and if small d is the internal diameter of the column, you are required to find out the diameter inside and outside. Suppose if the load is given to you, suppose if I take a load of 140 kilonewton, so this load I will call it as working load. If I subject it to working load, if I take the column, if the length of the column is say 3 meters, L is equal to 3 meter, and the condition what I have taken is one end is fixed and the other end is hinged. One end is fixed and other end is hinged. So you are required to find out the diameter by using Rankine's formula. So for Rankine's formula, you need the value of sigma c, and the value of sigma c is 320 MPa. You need Rankines constant, and Rankine's constant, let us take it as 1 by 7500. We will take a factor of safety is equal to 2. Because working load is given, so crippling load will be working load into factor of safety. So here factor of safety, if I take it as 2, so you are required to find out the diameter D and D. Diameter D and D. So here the calculation procedure remains the same. The unknown things will be D and D. Condition is this internal diameter is 0.8 times of the external diameter. This is the condition. So this internal diameter is 0.8 times of the external diameter. So the possibility of change is in this only. I can take it as 0.7 times of D or 0.6 times of D. So where D is the internal diameter and capital D is the external diameter. So using these conditions, we will try to find out the diameter of the column. So here we know Rankine's load is given by sigma c into A divided by 1 plus alpha into L by K. Sigma c is given to you, alpha is given to you. You can find out L. So here one end is fixed and the other end is hinged. So this is a fourth category. Here the effective span will be equal to L by root 2. Area you will have to find out. They will remain in terms of the diameter. You will have to find out K. K is nothing but under root I by A. Again the values will be in terms of diameter. So finally you will be knowing this P which is given to you in the problem. You will have to find out the unknown diameter here. So one by one we will go on finding out the values to find out, you substitute in this formula. So here let us begin with given D is equal to 0.8 D. So this condition we are going to use. So here we will find out the area. So area of circular section is pi by 4 into outer diameter square minus inner diameter square. So outer is capital minus inner is small. So this will be equal to pi by 4 into D square minus this small d is 0.8 times of D. Be careful, this should be in 0.8 D square. And don't write as minus 8 D square. Be careful about this. So whole thing should be in the bracket. If you simplify this, you get the value of area as 0.283 D square. 0.283 D square is the area. Let us go for the moment of inertia. Circle both Ixx and Iyy, they will remain same. So here moment of inertia of a circle is given by pi d squared by 4. It is a hollow, so pi d squared by 4, or I can write it as pi d squared by 64 into outer diameter minus inner diameter. So moment of inertia is pi d raised to 4 divided by 64. So here if I substitute the values, so this will be equal to pi by 64 into capital D fourth minus, again be careful here, it is in the bracket 0.8 d whole raised to 4. So this will be 0.8 times raised to 4. So if you simplify this, you get the value of I is equal to 0.0289 d raised to 4. D raised to 4. So in Rankine's formula, you need the value of K. So K will be equal to under root I by A. So where I is 0.0289 d raised to 4 divided by A is 0.283 d square. This will be under root. If you simplify this, you get K is equal to 0.3196 d. 0.3196 d. So here one more thing what we need is the effective length. One end is fixed, other end is hinged. So L will be equal to L by root 2. So here actual length of the column is 3 meters. So this will be 3000 divided by root 2. If you simplify this, you get 2121.32 mm. 2121.32 mm. Getting all these data, we will substitute in the Rankine's formula. And we know Rankine's formula is given by P is equal to sigma C into A divided by 1 plus alpha into L by K whole square. So sigma C given in the column is 320, MPa is nothing but Newton per mm square into area. We have got the area in terms of diameter 0.283 d square divided by 1 plus alpha is 1 by 7500 into L is 2121.32 divided by K is 0.3196 d. This is to be square. So this is a crippling load, and you know the Euler's load is given by 140 is the working load into factor of safety given to is 2. So this is in kilonewton. So let us convert it in Newton. And if you simplify this, you get a equation all in terms of d. So here you see d, it is to raised to the power of 4 d square d. You will have to go on doing the calculations. So let me see some step by step here what is the value you will be getting. So if you see to this equation, if I cross multiply it, it will be 280 into 10 to the power of 3 into, I'll cross multiply this, 1 plus 1 by 7500 into 2121.32 divided by d 0.3196 d square. This will be equal to 320 into this one. So this value will be equal to 90.56 d square. If I multiply this and if I simplify this, so this will be 280 into 10 to the power of 3 plus, if I simplify this and multiply by this value, first simplify this, divided by 7500, then you multiply by this, you get the value as 164.47 into 10 to the power of 7 divided by d square is equal to 90.56 d square. If I take LCM and cross multiply, you get here, this will be equal to 218 to 10 to the power of 3, LCM it will be d square, plus 164.47 into 10 to the power of 7 is equal to 90.56, d square into d square will be d raised to 4. So you get a quadratic equation here. If you simplify this equation, d4 minus 3091.87 d square minus 181.62 into 10 to the power of 5 will be equal to 0. So this is a quadratic equation. So you will be getting d square here. D square is equal to, we know root of equation is minus b plus or minus root b square minus 4ac whole divided by 2a. So if I use this, instead of d it will be d square here. So d square will be minus b, minus 3091.87 plus under root b square 3091.87 square minus will be plus 4 into a is 1 here, c is 181.62 into 10 to the power of 5 whole divided by 2. A is 1 here. So if you simplify this, you get the value of d square will be equal to 6079.4 mm. If you find root of this, you get the value of the diameter as 77.97 mm. This is approximately equal to 78 mm. This is the external diameter. Internal diameter, we know it is given by 0.8 times of the external diameter. Condition is given to you. So if you substitute this 0.8 into 78, you get the value of internal diameter as 62.4 mm. 62.4. So here you have to find out diameter. So mathematics is involved here. So be careful in doing the calculations. Usually you commit mistake in finding out this diameter. So be careful here. And important thing is to find out I. So these are the different categories of problem that you see in columns. Section is given to you. You will have to find out the load either by using Euler's theorem or Rankine's theorem. Or load will be given to you. You will have to design the cross section either by using Euler's theorem or Rankine's theorem. Thank you. So this is today's video. We will end up with the column section here. So please subscribe the channel for more videos. Press the bell icon for notifications. Comment for questions in the question sections. Thank you.